Problem 1.16 on page 18 of your lab manual is a really good problem for learning how to handle challenges when you've got two units that you need to convert. In this problem we have an oxygen molecule moving at 4.78 times 10 to the 4 centimeters seconds to the minus 1. So we have units of centimeters and seconds. We are asked how fast that molecule is moving in miles, hours to the minus 1. That has units of miles and hours. We're going to need to do two conversions. We'll need to change our length from centimeters into miles, and we're going to make our time units change from seconds to hours. To do that, we are going to need to do several calculations. But let's start with that whole minus 1 thing. What does that mean? Well, when you see whether it's a number or a unit raised to a negative exponent, it's the same as saying, I want you to take the inverse. So centimeters, seconds to the minus 1, is the same as centimeters times 1 over seconds. Now you could put that together in one fraction and have centimeters over seconds. You could do your slanted line and say centimeters slash seconds, which we read as centimeters per second. And we understand that that second, the unit that's on the bottom, has an invisible 1 with it. Same with miles, hours to the minus 1. It's the same as saying miles times 1 over hours. Miles per hour, which can be written as miles over 1 hour. When I need to travel 65 miles per hour and I ask how far do I go in 1 hour, you tell me 65 miles. I go 65 miles in 1 hour because it's understood that there's a 1 with the unit on the bottom. Now whenever you have two units to change, folks that are really good at math, you can do it all in one long unit conversion step, and that's great, but for folks like me, you might find that it's easier to solve it in separate parts, one unit at a time. Then we can follow the rule that we always start with only one unit. Any values that have two units go as conversion factors. So if in this problem, we're going to first start by converting our centimeters into miles. And the number of centimeters we're going to have when we have a value of 4.78 times 10 to the 4th centimeters seconds to the minus 1, the 4.78 times 10 to the 4 goes with our centimeters. The numerical value always goes with the unit in the numerator, with the unit on top. And we've talked about what the unit is, what value is going to go with the seconds in 4.78 times 10 to the 4 centimeters per second. It's going to be 1 second that we need to convert into hours. I say we take these as two separate steps. And then in the final step, we can divide our answer for the miles by our answer for the hours, and we'll end up with the units of miles per hour. So let's get started. Number 1, converting our centimeters to miles. We could look at a conversion chart. We have one on table page 17, table 2.2, and we are told that 1 mile is the same as 1,609 meters. Now it didn't tell us how many centimeters that equaled, so we will need two conversion factors. You either need to memorize or have memorized that there is a relationship between centimeters and meters. The way I remember it is I ask myself which unit is larger. Meters is larger than centimeters, and I give him the 1. So I put the 1 beside whichever unit is larger. Now for centi, I think of 100 cents in a dollar, 100 years in a century, and so I can remember that the smaller unit, who gets the number greater than 1, when it's a centi, for the prefix, it's 100. We have now two conversion factors. one that will have miles and meters in it, one that will have centimeters and meters in it. We can make a pathway now. We have friends on Facebook. Between centimeters and miles, they share the friend of meters. So let's do a little arrow chart to help us plot our way. We're going to go from centimeters to meters and from meters to miles. And I'm going to do it all in one long step because that way I save time and I don't run the risk of copying down a number incorrectly. We'll start with our 4.78 times 10 to the 4 centimeters. That's the value that's by itself that we're trying to convert into miles. I need to get out of centimeters and into meters. To do that, I will put the unit centimeters on the bottom and I will put the unit meters on top. I could put the numbers in now, but numbers kind of freak me out. I'm going to stick with letters. I can handle letters. I know that M and CM can go into the same fraction. I also know from my table 2.2 that my meters can go in the same fraction as miles. We have a relationship between those two units. I'm going to double check before I put in my numbers that my units cancel out. I don't want to be in centimeters anymore, so I divide it by centimeters. They'll equal 1 and go away. I get into meters, but I've already told myself that my final answer needs to be in miles, so we didn't stop with meters. Meters divided by meters cancels out. We're left with miles on top, which is great because my note to myself tells me I wanted to end in miles. Now that the units have canceled out, we can plug in our numbers. We said that one larger meter was the same as 100 centimeters. We were given in a chart that 1 mile was the same as 1,609 meters. To solve, I will start with 4.78 times 10 to the 4th. I could multiply by 1 and 1 again, but I'd just end up with 4.78 times 10 to the 4th. I'm going to want to divide by 100, and I'm going to want to divide by 1,609. What I have here are the two ways to put it in your calculator, depending on which kind you have. You can either do 4.78 times 10 to the exponent 4, or 4.78 times 10 y to the x 4. You'll find if you hit the enter that you'll either see 4.78 e to the 4 or 4.78 to the exponent 04. Either one's fine, you're on the right track. Now you can just divide by 100, divide by 1,609. You hit either equals or you might have an enter key. And when you do that, if you're in scientific notation on your computer, on your calculator, you will end up with 2.97 times 10 to the minus 1. Now again, it may say e to the minus 1, or it may just have a minus 1 there. But whenever you see e or just raised to the negative 1, I need you to write times 10. If you don't have it in scientific notation, it would look like 0.297. I'm going to keep it in scientific notation because it's for my future problems it'll be easier, plus I'm trying to teach you guys how to read these numbers. So on the next tape I'm going to do the conversion from seconds into hours and we'll give our final value. So come back for part 2.